Coming up on the final FRC Open Alliance Show for REEFSCAPE, it's the RoboSpartans 4639 are on. They're talking about their current progress, lots of great demos that you'll be able to see for what they're doing, talking about some of their Choreo pathing as well too, what maybe some of their future plans are, and they're competing week one, so they're taking, I think, a very apt approach to making sure they get stuff right and focusing on consistency as well too. They'll also be talking about how they're going to do some weight saving, had to take a couple things off as well too, and a lot of great things that teams can learn from in this as well. So let's learn more about their progress coming up here on the FRC Open Alliance Show. This video on fun is brought to you by our viewers, supporters, members, and also in partnership with the following. Osh Cut is the premier metal cutting service for first teams. No minimum order, options for same-day turnaround, 3D tube laser cutting, and with nearly 500 variations of metal in stock and ready to cut. Just upload a file and claim your 50% off discount when you scan the QR code or go to funroboticsnetwork.com/OSHCUT. Build your alliance with so many other FIRST alumni who go to Kettering University. Every student at Kettering experiences their cutting-edge co-op programs that seamlessly blend the professional and academic worlds. Kettering co-ops are a fully immersive working experience at the leading edge of industry. Head on over to kettering.edu/first to learn more about their incredible programs and to get more information. Let's welcome back 4639, the RoboSpartans coming in, who have been having some awesome progress on the robot. We got so much to demo and to go through here today. I'm very excited to go through both stuff on the mechanical side as well as programming, some of the Choreo pathing as well too. So guys, welcome back. Introduce yourselves and let's jump right in.
Thank you. My name is Cameron. I'm the president of 4639.
I'm Jasper. I'm the build director.
And I'm Aditya. I'm part of the programming team.
Okay, so first thing we wanted to get started off with was kind of just our robot build progress. So here I have our robot on video. And so kind of the main thing I wanted to show off is our cascading elevator. So we have a 2-stage plus carriage. So Jasper, if you want to lift it up and demonstrate that. So we're currently running this on a, I believe, a little bit less than 12-to-1 ratio. And this height is more than enough for us to score not only from L1 through L4, but also all the way to the barge. And that's kind of demonstrated in the videos. So another good thing about this is that the speed of this elevator is really sufficient enough for us to be able to get kind of the quick cycles we need in this game. So, you know, kind of one of the main design points we were emphasizing on was speed. So like I mentioned in the previous video, we originally were going to do a continuous design, but we changed that to cascade simply because of how much faster the cascade design is. So just to give a closer look, we're running 2 Krakens, and each of them are on max planetary reductions. And we also have kind of just this pulley rigging system set up. And then over here for the chains, we have it hooked up using the thrifty chain blocks. So that's kind of our elevator build. And then another thing that we added was these A-frames. So originally when we first built our elevator, we kind of saw that it was not very structurally stable. However, once we added these A-frames, this helped us ensure that it's not going to have as much shear force on the bolts which are holding it from down there. So pretty much, yeah, the point of, currently we're considering also adding some lateral frames on the side over here. But yeah, that's something we'll have to see on the field once we test it out a little bit more. So next thing I wanted to talk about was our scoring subsystem. So currently we're in the process of building the gearbox and the actual kind of structure of it. And over here we have the scoring part of it itself. So kind of how it goes on is it just pivots there, and then it's able to pivot back through the strings to pick it up through the funnel. And as you can see, the funnel's back there. So the funnel pivots up. It's going to be able to drop the coral into the intake, and then this pivots back out, and it's able to score it in whatever level we want to. And speaking of the funnel, just wanted to show off the funnel real quick. So we're running a single vortex for the pivot, and then there's no max planetary reduction on this. However, there is a belt reduction. So we're running a 36 up top and a 15 on the bottom, and these are both HDD. And so that gives us roughly a little bit less than 3-to-1 ratio. So I kind of wanted to demonstrate the funnel a little bit to just show how it works. So Jasper's going to go ahead and grab a piece of coral real quick. And then, yeah, pretty much, as you can see, we made it not symmetrical because one of the things that we saw a lot of different teams struggle with was that we saw that whenever teams made both sides of the funnel symmetrical, it caused issues with whenever both sides of the funnel were symmetrical, it pretty much caused issues with getting stuck. So here, now I'm gonna pretty much let him actually demonstrate how it goes. So pretty much, if that's the scoring subsystem, it would go down with C, and it would get picked up by the scoring subsystem, which is there. So yeah, we don't really have any issues with it getting stuck. So that's one of the good things of our funnel. And yeah, if you want to take those scrolls. And then last thing I wanted to show off was our climber. So our climber design, we changed it last minute. We were originally going to do our compact climber design. However, the reason why we switched over to the EveryBot design was mainly because we saw that the EveryBot design was much easier for actually latching onto the cage because of these hooks that compressed over here. And because of this, we switched over to this because during our testing with our original climber design, we saw that it would take upwards of 45 seconds to a minute to actually align ourselves properly. So we saw that this was a much easier solution for lining up. And then yeah, for during the climbing sequence, whenever this goes back, our funnel just pivots all the way up like so. So that gives us perfect clearance for the cage to make sure we don't get any of those major tech fouls with the anchor or the chain. So yeah, that's pretty much it for the robot build so far.
I'm going to ask an ex-driver question here. And looking from your climber that you have, I noticed that the climber is a little offset, right? It's not in the center of your robot on it. Have you guys tried with that climber in that position of doing a climb yet? And has your driver been able to align pretty well by doing that?
We haven't been able to test it with this angle specifically. However, once we mount our motor with the spool, we're able to adjust the angles however we want because the spool can just bring it back to whichever angle is best. So most likely we're just going to have it set at 90 degrees, but it's just because of these elastic bands which are cooling it back right now. That's the main reason it's this way right now. But once we actually add the spool with the 80-to-1 gearbox, it should be able to hold it upright. So it makes it much easier for driver alignment. And something I forgot to mention about robot build actually was, as you guys can see, our algae intake is not on a robot, and that is for one main reason, that's weight. So the 115-pound limit is really gonna sneak up on everyone, I feel like, this year. And so that's kind of one of the major decisions we had to make. It was taking off that algae intake. So as you can see here, we just took it clean off. It reduced our robot weight by a good 16 pounds. So for our first competition, we're just planning on not having it. However, for future competitions, we are planning on possibly developing a smaller algae intake, which could have the same function as the old one, but it's much lighter and also much more compact. So that way we could still fit within the weight limits and also have that intake on there. So yeah.
You're definitely not alone, by the way. Another team that we had on this week, Clockwork, as well, too, ran in the exact same thing that you all did with weight savings, and they were reducing weight in many different ways on their robot. So, yeah, it's definitely a hard challenge this year to try to get everything under weight.
Yeah, one of the other things we also did for weight saving, you see, we pocketed a bunch out of our elevator. So all of these bars are pocketed. This A-frame is pocketed. You see the second stage of the elevator is also pocketed. Our funnel is pocketing. So you see there's a lot, definitely much more heavy pocketing than there was in our previous episode, simply because of weight saving, because we want to fit as much as we can on our robot without going overweight. So yeah, it's kind of one of the challenges we've been facing.
I still think it's coming together quite nicely. I mean, this looks great so far, y'all. So I can't wait to see even more videos on your Chief Delphi build blog and more like that as well, too. What else do you want to jump into? We got some great stuff, I know, with programming and with Choreo pathing and stuff. What comes up next for y'all?
So for our autonomous, we have 5 paths here that we've planned out so far. So we have these 2-note paths over here. And then we've tested these. We've done some preliminary testing just with our drivetrain. And we've posted some of those videos on our Open Alliance blog. And so now that we have a lot of our other subsystems mounted on the robot, we're going to be testing and fine-tuning these. So I'll play one of these. And so in our testing, we've had to set a lot of constraints. So you can see it's not just the start and the end here. There's a lot of posed waypoints in between to make sure that the path the path planning in Choreo is slowing down the robot adequately to make sure we don't get any hits on the reef. We've run into the reef a couple of times, so we're trying to make sure that doesn't happen, especially not in a competition. As far as our programming goes, code-wise, the main thing we've been focusing on is programming our elevator. For when we're coding our elevator, one of the main challenges that we have is making sure that our end effector, which we showed it can go backwards and forwards, we have to make sure that when the elevator is going up, it doesn't collide with the elevator and break something. So the first way we tried to fix that is by tracking in any command which subsystem should be the last to move. So if the end effector was the last to move, then the elevator should go all the way up to its position, and only then would we let the scoring start moving. But one of the problems we had with that is that if it started in a bad position, then it would just go up in that position, and then the elevator might break. So instead, what we did was we had a kind of three-stage process where the scorer would move to a transition state, then the elevator would go up or down, and then lastly, we would put the scorer back where it needs to be to score in whichever choral or human player if we need to intake whatever we have. And then as for our control, how we're controlling the elevator, we're running a feedback loop, PID, on the motor controller itself, on these two talons we have controlling the elevator. And then we're also combining it with a feed forward loop using sysID. So we're using our feed forward loop to get the elevator close to its position, and then using PID to fine tune the position to get it exactly where we need to be. So that's pretty much it for what we have regarding programming right now.
So what are maybe some of your next steps that you want to try to accomplish from programming on your team?
Could you say that again?
What are some of the next steps that you really want to try to get done on your team that way?
Well, we still need to make a lot of progress on our climber, how that's going to work, and then also the funnel. Like Param said, we need to move that up when we're using our climber, and then the climber itself will also require another subsystem. Another thing we notice is that when the elevator is up, the robot is really easy to tip over, and we have a video of that where we were testing and we almost tipped it over. So one of the things we're going to try to accomplish is that making sure the robot could not possibly tip over when the elevator is too high.
Yeah. So one of the ways that they were experimenting with that the other day was they were experimenting with kind of trying to slow down the robot speed whenever the elevator is at some certain set point. So whenever the elevator is above some certain height, one of the ideas we had was kind of slow down the robot speed until the elevator comes down, so that driver error can't take way and cause the robot to accidentally tip over mid-match. And so one of the things that we saw was whenever we were doing our tip tests on our own, we saw that this was occurring with just the elevator. The scoring wasn't on there yet, so we're already assuming that whenever we do mount the scoring with all of its components, it's going to be much more top heavy whenever the elevator is fully extended, which is going to make tipping even easier. So that's kind of the things that we're considering. And another thing that we're trying to accomplish programming wise is that we're basically kind of trying to make a huge integration of all of our subsystems. So we're just trying to figure out the most optimal way to make sure that nothing collides and make sure that we're not going to have any issues with anything else. So yeah, and last thing regarding programming is vision. So Odyssey, if you want to talk a little bit more about vision.
Yes. So we have one of our limelights mounted on the front of the robot over here. Is that even front?
Yeah.
Yeah. On the front of the robot over here, where we're going to be scoring. So this limelight is going to be angled directly at the apo tags on the reef. Right now the angle is a little much, but we're getting another mount so that it will be able to see directly to the reef. And so we also have another limelight planned to go on the other side that will be able to see the coral intake station or the processor or whatever else we want it to see on the back. And so we have two main methods that we're going to be using for our vision. The first one is a global vision, which will just aggregate all of the vision measurements that every camera sees. And then the second one is a targeted vision, which is inspired by 6328, where when we're specifically trying to target one apotype, so for example, when we're trying to score in the reef, it's going to ignore all of the other vision measurements and only focus on the one that's the most precise. And so that way, we hope to avoid errors from apotypes that are a lot further away that could interfere with the precision of our scoring.
Well, RoboSpartans on here. I mean, you're competing week 1, so that's coming up very quick, I know, for your team. So lots to get back to and lots to work on for that. Before we let you go in there, anything else you want to wrap up with or tell us about before we let you go?
Nothing really specifically. I guess the main thing that we kind of want to add in a little bit was that, so kind of coming from a strategy perspective, so we've been really making these all-time paths based on strategies which we've decided on early on in week 1 and week 2. And one of the things that we prioritized this year was getting all-time paths done early, because something that we struggled with in the previous 2 years was all-time paths. We always waited to the last minute to do those paths. So it's definitely been much more helpful for us to be able to do these paths much earlier on. And so yeah, I guess the big thing that we need to do now is integrating all the subsystems on the robot with these paths that we have. So kind of right now we've just settled with 2-piece paths for now for week 1 due to simplicity. But depending on robot speed, depending on how fast we're able to optimize our robot controls, we are considering doing some 3 pieces for Tomball. However, that's still up for debate, and we're just currently using these 2 paths which we made. And then kind of the priority list was make sure that we have a path from every single starting position on the field, so that we're flexible with all teams, whether it's a team that really wants to do, more than 2 pieces to 3 or 4 pieces, or whether it's just a team that is going to do just a leave, because we want to be flexible with every single team. So that was kind of the big things, have as many paths as possible so that we're able to be flexible with whatever team we're paired up with during quals.
And I think if you can just be really consistent with that, I think you're going to be in great shape, right? And having that flexibility, like you mentioned, I think is more important in many cases than even having a 3-piece plus something like that too. So we can't wait to see, how your team does. Keep following along on their build blog to get all the updates that they're doing. And of course, watch Tomball week 1 as well too. So good luck to you guys. Thanks for showcasing everything that's going on. And we can't wait to see how you do in week 1.
Thank you.
Build your alliance with so many other FRC alumni who go to Kettering University. Every student at Kettering experiences their cutting-edge co-op programs that seamlessly blend the professional and academic worlds. Kettering co-ops are a fully immersive working experience at the leading edge of industry. Head on over to kettering.edu/FRC to learn more about their incredible programs and to get more information. Cut is the premier metal cutting service for FRC teams. No minimum order, options for same-day turnaround, 3D tube laser cutting, and with nearly 500 variations of metal in stock and ready to cut. Just upload a file and claim your 50% off discount when you scan the QR code or go to funroboticsnetwork.com/OSHCUT.